Hello, everyone. My name's John Darlington, and I'm the Director of Projects for World Monuments Fund in Britain. And it's my pleasure to host today's Coastal Connection workshop number 4. We're just going to wait a few seconds more just to allow lots of people who are waiting into the workshop, and then we'll get going. But I think it's going to be an absolutely fascinating session. And as I say, number 4 in the Coastal Connection series. Whilst we're waiting for those people to come in, I should just say that it is our fourth workshop. We've had 3 already. We've started by looking at understanding significance for coastal heritage sites. Then we moved on to sustainable engineering solutions. And the last workshop we had was looking at communities and intergenerational stewardship. This particular session is all about mapping, modelling and monitoring. And the whole idea of Coastal Connections, which is a collaboration between World Monuments Fund and English Heritage, is the word is in its title. It is to connect up people who work in or who are interested in coastal heritage sites, coastal heritage, and connect those people who are dealing with issues around coastal climate change and erosion. So we're taking a really pragmatic view of what might be happening in the UK might have great resonance and be worth sharing with what might be happening in Rapa Nui or South Asia or in the African continent. So the idea is to cross-fertilize these ideas, these practical, pragmatic solutions, and share them under a variety of different themes. The format for this afternoon is as previous sessions, but for those of you who don't know, after this quick introduction, I'm going to hand over to Alex Kent, and I'll introduce him in a minute, who's going to give us a bit of a provocation, a bit of thought about mapping and monitoring, which will just get our thinking juices going. And then from that moment on, I'll hand over to our 3 wonderful speakers who have each of them got a fascinating project which tells of their experience of mapping and modelling and monitoring. It's quite a technical session, this one, but hopefully it'll be accessible to all. I'll ask you to let the speakers do their presentations. They'll talk for 10 or 12 minutes each or so. But after each has spoken, there's going to be a little bit of time for any questions of clarification. So I'd urge you to ask questions in the chat. And then at the end of the 3 presentations, I will pose those questions to the speakers. And then after that, what we'd like to do is to have a bit of an interactive session where we'll be dividing those people who wish to stay on into a number of different digital rooms to have a discussion about some of the issues that they've heard. And then we'll come back together again and close at 5:30 UK time. So that's the plan. And not that anything ever runs to plan, but we shall hope for the best. So having said all of that, and having reminded you to post those questions, really important, post those questions, I'm going to hand over now to our first speaker, and this is Dr. Alex Kent. And Alex will be known to anyone who's attended these workshops before because he is our Coastal Connections project lead, jointly funded by English Heritage and ourselves. Alex is a geographer. He's got an academic background, but a very practical background as well. He is the person that you go to if you want to understand anything about mapping and cartography. So he is the best person to perhaps set out the context of this conversation. So Alex, over to you.
Great. Thanks very much indeed, John, for that very illustrious introduction. I'll do my best to live up to it. So thanks very much indeed. So Kira, let's have the first slide coming up, and I'll kick things off and hopefully start us to think a little bit about what we might mean by mapping, modelling and monitoring, and how we can relate that to coastal connections and also to the wider coastal sites that we're dealing with when we think about this network that we're building. So let's hope we have the next slide for a second. I'll get things going when we see those questions. Great, yeah. Some of you actually, just before we get into that, some of you might recognize this world map. This is Marie Tharp's world map that she developed in the 1960s of the oceans, and that, in a way, I suppose, is a good place to get us to think about what we mean when we map something, when we model something, when we monitor something, and particularly then how these processes, and I very deliberately call them processes, can help us to manage heritage in coastal environments. We might think about mapping in terms of telling us what is where we're interested in spatial relationships. We might be interested in the coastal environment in terms of maybe preservation by records, having a map of what is where can tell us something itself becoming a record. And that in itself is something that could be of value and particularly versatile. We might also want to look at modelling and thinking about the different variables, particularly if we're dealing with sea level rise, the impacts of coastal processes, coastal erosion, if we want to know maybe what the impacts might be. And obviously through monitoring, through sensors, we might want to understand a little bit about how things are actually changing, so we get an idea of risk and maybe ideas as well about the rate of change and therefore the risk associated with those rates of change. But I want to also suggest something to you as well, because we might want to think about the whole process, whether it's mapping, modelling or monitoring, in a slightly different way. All of these processes are selective. They take some aspects of information and leave others out. So that set of processes are selective. They empower some people and perhaps they disempower others. And they can also empower some communities and maybe not serve the interests of others. So that's maybe a theme that we need to think about. Who owns the technologies that we're going to be learning about perhaps and seeing applied? So let's crack on the next slide, Kira, and I'll give you a sense of what I mean. If we can get the next few slides to illustrate some of these things. So some of the coastal connection sites that we've already heard about as part of these workshops, for example, again, involve aspects of mapping, monitoring, and modelling. So Mussenden Temple in the top left-hand corner here in Northern Ireland, perched right as it is there on the cliffs near the Londonderry coast. And again, a site like that, if you're not doing perhaps any monitoring of movement, of cliff movements, you might be forgiven for thinking that the temple is going to fall into the sea at any given moment. But actually through monitoring and using sensors that the National Trust have installed to understand what those movements are, actually we can tell that the movement that we're seeing, the vibrations we're seeing, are more to do with the trains going through the tunnel underneath the cliff than actually the processes of coastal erosion. So monitoring in a way can give us that confidence. And again, the monitoring that we're applying at Hurst Castle as well after the collapse in February 2021 of the whole site, the whole castle can give us an understanding of areas that are particularly vulnerable if we're thinking about the processes, again, of erosion, but also of its isolated position and its vulnerability to the movement of the sea. Scott's huts in the Antarctic that we see in the bottom left-hand corner. Again, the terrestrial laser scanning, the ground-based LiDAR that's been applied there, and also at Rapa Nui in the bottom right there on Easter Island, to capture and preserve by record what these places are like, not only for the purposes of monitoring, but also for interpretation, making those digital models more accessible to others. So we can think of this, if we move over to the next slide, Kira, thanks. Think of this as a process not just of individual exploration, one that involves discovery and manipulation, as well as some of those data. So let's see, hopefully we can get the next images up. And then once we're thinking about those. Yeah, and mapping again can help us to take that broader picture. This is the World Monuments Fund watch sites that we've mapped that are within 5 kilometres of the coastline. So again, dealing with the multiple scales available to us can give us a more strategic insight, as well as maybe understanding specific sites. And again, it's one of the key hallmarks of coastal connections that we're thinking about the perspective, the changing perspective that is really looking beyond the site itself to other sites that face maybe similar issues. And that's something that we can appreciate it with a more global perspective. Okay, crack on, Kira. Let's move on to the next one. And this process of mapping those sites, of course, as I've already mentioned in another workshop, is part of what we're doing to understand what those sites are. Of course, those sites are at risk that we can connect with as well, that we might not know about already. And again, we see community mapping initiatives like this in Colombo that have been created by iDiscover to effectively understand what it is about heritage sites that communities find or deem valuable. So it's not necessarily a top-down approach. An actual bottom-up approach for mapping can be very useful through that process of selection, that politics of selectivity as well, to understand what it is that certain communities feel valuable about sites and significance. And that significance might be derived from, of course, other elements, but listening to communities and allowing them to map those sites through that process can be a very enlightening and insightful one as well. Okay, Kira. Yeah, and again, a couple of other examples. Feel free to just move on, Kira, as I go through these. So again, this is using LiDAR to detect erosion and attrition across the North Cornwall coast. LiDAR, again, light detection and ranging, a way of sensing landforms, particularly terrain, very, very useful for monitoring coasts. And again, coastal observatories all around the world use this technique to understand morphology, how the shape of the coastline is changing. And just emerging there, hopefully we'll see in a second, is also another method of modelling. Hopefully this will show, there it is, yeah, the Climate Central Coastal Risk Screening Tool, again using multiple variables to provide a global data set for modelling, in this case, coastal flooding, to get an idea of those different areas around the globe that are going to be below water at different times using different modelling scenarios to get a sense maybe of risk and vulnerability. Those in this map here, New York shown in red as those areas that are below a metre of water. So again, that can help us to get an overview at a very global site, as well as perhaps a more local view as well. Okay, Kira, let's move on. So just before then we hear the speakers, maybe some questions to think about to sort of provoke some of your thinking here in listening to these different case studies and the technologies. We could think, particularly if we're coming to this workshop from our own coastal heritage sites, particularly if you're a site manager, you might ask yourself, perhaps what are those technologies that can maybe help us to understand coastal heritage more effectively, and perhaps most effectively? How can the mappings, perhaps taking that term to mean all of these different processes, how can they actually encourage a sense of stewardship towards those sites? If we map something, does that mean that we have a greater sense of ownership? There's a huge link between the processes of mapping and empowerment, and certainly feeling a sense of power as well. But that power works in two ways, in terms of what is shown and what is omitted, and of course, who owns the data. Again, thinking about who owns those technologies. So mapping does not necessarily have to be high tech. So we might also ask, these processes of mapping, modelling and monitoring, are they perhaps equally useful for different sites? So for every site, would it be useful to have a particular technique, or maybe all of those techniques? In which ways would these different techniques perhaps help you to better understand and manage your own site? That might be something that you think about as we listen to the talks, and then we might revisit when it comes to the discussion at the end. But have a think, and we look forward to hearing from the next three speakers as to their individual case studies and techniques. Thanks very much indeed. Over to you again, John.
Alex, wonderful provocation there, particularly getting us to think about the fact that all maps are biased. You know, there is a bias inbuilt in every single map, and every map deals with the politics of selectivity. So just to have that in the back of our minds as well. Okay, we're now going to move to the first of our three speakers, and I'd like to introduce Soetkin Verwust, who is from Belgium. She's an archaeologist and a geographer. She's got a PhD in historical cartography. But the main thing that Soetkin's going to come and talk to us about is around the Testerep landscape. So this is a Flemish seascape, as you can see there. And she's going to be exploring ways in which she can look back at the past around this landscape and seascape, but also bring it through into the future and through the present into the future, with some very interesting ideas about using gaming technologies and the like. So without further ado, Sudkin, over to you.
Thank you so much, John, for that introduction. Happy to move on to the next slide, and very happy to be here to tell you a bit more about this project of ours. So it's been running for 2 years now. It's a big research project. It will run for 2 more years. And indeed, Alex was talking about different scales, also different time scales. I'm guessing ours is quite large, as we're looking back 5,000 years to see how the Belgian coastal landscape evolved over that time. And we're trying not to just focus on land, but we're also looking offshore and trying to integrate both. Because the idea is, as you see on the picture on the left, that for most of its Holocene history, the Belgian coastal plain must have looked like this, so a natural tidal landscape. Whereas nowadays, it's more like the picture on the right, so a polder landscape, embanked, drained, with only a narrow strip of beach left, and then high-rise buildings on the coastline itself. And so we're trying to get a better understanding of what role was played by both natural changes and human interventions in shaping this landscape, and how that can also help us shape the future of this landscape by getting a better understanding of its past. So next slide, please. So I'm not doing this research on my own. We're a large consortium that consists of archaeologists like myself. We're doing the research on land. Then you have marine scientists from Flanders Marine Institute, or VLIS, who are doing research at sea. We're also collaborating with coastal engineers from KU Leuven, who are modeling this coastal evolution over those long timescales. And then finally, working with computer game developers from HOWEST, Digital Arts and Entertainment, who are creating visualizations of this changing landscape. And so the next slide is about our study area. So you might have been wondering why this project is called Testrep. You can move forward, Sierra. There you go. So the project derives its name from an island that used to be situated in the central part of the Belgian coast, and that was separated from the mainland by this broad tidal gully that ran more or less parallel to it, hence creating this island shape. And on the landward side, we know that during the Middle Ages, this gully silted up and people started building dikes along it, and eventually it was dammed off and it ceased to exist, really. There's only a very narrow watercourse left there, whereas this gully used to be about 1 kilometer wide. And we've also lost, presumably, a large part of the seaward side of this island, but we don't know exactly how much we lost. We know, for example, that the medieval city of Ostende perished during a storm in 1394, but how far this island once extended seaward is also one of our big research questions. Next slide, please. So in quite broad terms, we do have an idea about the big events shaping the Belgian coast. One of the main things we also know, and this is why our project runs for 5,000 years, is that over that period of time, relative sea level rise was more or less constant at about less than 1 millimeter a year. Whereas now, during the 20th century up to the present day, we've seen a massive acceleration. And here for this part of the Belgian coast, we're now at rates of about 5 millimeters a year. We also know that in broad terms, we have a landscape that 5,000 years ago was more or less a freshwater peat bog, that then 2,000 years ago changed into a tidal landscape with these big gullies like the Testrep Gully. And then 1,000 years ago, people started really embanking this landscape, massively transforming it. But the biggest transformation came probably at the end of the 19th century, when tourism really took off here and transformed this landscape and really fixed that coastline, which is something probably that in the long run we'll have to start thinking about, because it won't be sustainable probably over the long run. But so we have a broad idea about what's going on, but still lots of questions remaining about the exact position of that coastline over those 5,000 years, and also about human interference with it. Where were humans interacting with this environment? What archaeological traces can we still find of these? When were these gullies embanked? When were they closed off? What impact did huge storms have on shaping the landscape? So all of these questions form part of this research project. And the way we are tackling those is something for the next slide. So we're, first of all, collecting lots of data, both existing data and new data. So at sea, that's happening by our partner VLIS, and they are conducting seismic surveys at sea. So they're scanning the layers underneath the seabed to see what old landforms we can still find them. And they're also collecting lots of sediment cores to get a better understanding of this old landscape. Next slide, please. And then archaeologists like myself, we're collecting evidence on land, of course. We're looking at, for example, archaeological inventories to see when we have evidence for settlement or for certain types of land use. We're also looking at old sediment cores to see what that tells us about the natural configuration of the landscape. Where did you have these tidal gullies? Which parts of the land were flooded at what times? And we're also collecting new data through excavations, through geophysical surveys. We also had a bit of a citizen science project where we asked volunteer metal detectorists to come and help us out and to scan specific zones of interest for us. So all of that data collection, next slide, please. We then process all that input and put it in a GIS so that we can create these paleogeographical maps of both natural features and man-made features. And we do that for different time slices. So each polygon that we have in our GIS can get assigned to a different feature type, depending on the period that you're looking at. And from that, we construct these larger maps, also larger digital terrain models. And then next slide, please. So this mapping then feeds into the work of our coastal engineers, our modelers, who use that as base data. So we tell them, well, we think that 1,000 years ago, the landscape looked like this. We know it doesn't look like that anymore. Can you please help us figure out what were the main drivers of this change? So they have these mathematical models that can simulate the effects of tides, but also of waves or big storms. So natural features, but we can also mimic what humans are doing in the landscape. For example, extracting peat from it, or building dikes, or damming off gullies. And then we try to see what is really driving the change. To get more insight into this, and also use that to then help us think about nature-based solutions for the future. And then next slide, please. And then in order to make all of that information as accessible as possible, we're also working together with these computer game developers who are creating 3D imagery for us. So they're working on these stills, but also animations. And they've also created a computer game for us about a medieval city that's about to flood. And then you need to try and protect that city from flooding. Next slide, please. So really, on the one hand, this project is about gathering all this new scientific knowledge about the evolution of the Belgian coast. But on the other hand, it's also very much the idea to then use that knowledge to learn from the past and to create these nature-based solutions for future coastal protection. And on the other hand, also to raise public awareness, to make people more familiar with the fact that our landscape wasn't as static as it is nowadays, but that this used to be a very dynamic coastline, and that will probably have to be a bit more dynamic in working and then living on this coast in the future. So for that, we're working with a big group of stakeholders on different outreach initiatives, and that's one of my final slides. So, for example, in 2025, we're co-organizing an international conference, ICUA, on underwater and coastal archaeology. And the call for sessions is open right now and will run till the end of June, probably. So I encourage all of you to submit sessions for this. In 2025, we'll also be organizing a workshop on how you can use these historical analyses in present-day coastal defense management. And we're still organizing the details of that. But once we have a fixed date, I'll again be sure to let you all know, because it will be wonderful to see some of you there. We're also working on exhibits to get this message across. We've worked together with a musical theatre company who've created a play inspired by the medieval story of the perishing of several of these towns on the island, but using that really as a mirror for the present day situation. We also want people to go out into the landscape. So we're working on digital walks and bike tours and even kayak tours. And then a final thing that I'd like to highlight is something that might also be worthwhile doing in your area. It's CoastSnap. It's an existing worldwide citizen science project. And the idea is that passers-by can take a picture of the coastline by placing their phone in a holder. And then that picture gets sent through to researchers who can use that information from that picture to assess erosion or accretion rates in certain areas. And so we're hoping to enhance the use of this CoastSnap station by incorporating it in our walking tours and biking tours. On the Belgian coast, we currently have 2 of these CoastSnap stations, but we're planning on having more. And then also rewarding people when they take a picture by showing them a visualization of what that landscape used to look like in the past, be it through an old map or a view or one of the visuals that our team are creating. And then I have one final slide to let you know we also have a website and a Facebook page if you want to find out more. That's all from me for now.
Sudkin, thank you very much indeed for a very rich presentation. Lots of questions kind of sparked in my head, but we'll save some of those for later. I think if you hadn't got a chance to capture some of those QR codes, we'll find a way of kind of circulating that information, because the QR codes, which I've dived into a few, in fact, I lost a lunchtime diving into a few, well worth a look, particularly around how you engage people in coastal climate change, this idea of a much more dynamic landscape than people perhaps perceive it to be. Thank you, Sudkin. I'm going to move straight on to Amira Al-Bushani. Amira is a PhD candidate from the University of Twente in the Netherlands. And the reason we wanted Amira to speak is because she's in the middle of a kind of a live research project, as Sudkin is, and she has a particular ask of us as people who are watching this presentation, involved in this presentation. But she's particularly interested in how you model complex systems and how you integrate stakeholder expertise into those systems. And the focus is of Kalhat in Amman, a World Heritage Site. So straight over to you, Amira.
Thank you for this introduction, and I'm happy to join this workshop. So thank you for this opportunity. My project starts with using the geospatial temporal tool to understand the complex system of the management of the world cultural heritage sites. So it will be from the fuzzy cognitive maps to agent-based modeling for modeling multi-factorial and multi-stakeholder decision-making for enhancing the management of the world cultural heritage sites. Next slide, please. Yeah, so my case study, it will be the ancient city of Kalhat. Kalhat was a significant international port and trade hub during the Islamic period, and it was associated with the Hermes Kingdom and has extensive commercial networks. The ancient city of Kalhat was added to the UNESCO list of the World Heritage Site in 2018 as a protected archaeological site, and it was nominated based on criteria number 3, 5, and 6, which manifest its physical fabric. So the most important thing that the physical fabric of the site of Qalhat represent the outstanding universal value of the site. Next slide, please. Yeah. So the case study or the Qalhat city located in Oman, and Oman located in the northern Indian Ocean basin, and it is significant area for the genesis and passage of tropical cyclones, and it has high vulnerability to climate change effect. And vulnerability, this vulnerability is determined through the past extreme weather that affect the ancient city of Qalhat, as you see in the figure in the left side. And Qalhat experienced significant precipitation in the year of 2019, resulting in the flood damage in the physical fabric of the elements of the site. As a consequence, the government has implemented the closure of the site to the tourists. And we argue even if the government trying to open the site to tourists, that we argue that as any World Heritage Site, it is accessible for damage from the human, even from the visitors, even from the development endeavors and the local community. Next slide, please. Yeah, so we argue that the World Cultural Heritage Site, we consider the World Cultural Heritage Site as a complex system which consists of multi-factors and multi-stakeholders. And it is hindered by a lack of effective tools considering these complex behavior of multi-factors and and involving the multi-stakeholders. The multi-factors, I meant by multi-factors that we have to consider the natural factors and the anthropogenic factors that may influence the site. Next slide, please. So to tackle this problem, we are planning to develop a dynamic management tool. Actually, it's a dynamic spatial temporal management tool to optimize the decision-making for the cultural heritage sites. And that will be through the convert the expert knowledge of causality into a causal model, which is using the fuzzy cognitive mapping to convert the qualitative data to quantitative data. Then we will create a learning fuzzy cognitive map by employing the machine learning techniques and utilizing the historical data to enhance the efficiency of the fuzzy cognitive mapping. Although the fuzzy cognitive map, it's the best approach to convert the qualitative data to quantitative data, but it cannot detect the spatial aspect of the problem. So we are trying to combine the fuzzy cognitive map or translate the learning fuzzy cognitive map into an agent-based modeling, and that will help us to predict and monitoring the impact of each factors and each human intervention on the system, and predict these kind of influence that that influence each element in this site, and that will help us to measure the state of the outstanding universal value of the site. So via agent-based modeling, we can implementing trade-off scenarios that help the stakeholders or the decision makers to take the right decision in the right time. Next slide, please. And to achieve this goal, first we are trying to elect the knowledge from about the factors that impact the physical fabric of the site, the management procedures and recreational activities, especially the tourism aspect on the World Cultural Heritage Site. And from the graphic, we are trying to drawing the interaction between the factors that may including in this system, and that will help us to predict the damage and the impact of each factor, and that will help us to understand the state or measure the state of the outstanding universal value of the site. Next slide, please. To do so, we are determining our stakeholders who has to be involved in this system or to provide their knowledge in the system. Consists of the World Cultural Heritage Site managers and experts and the site users. This will be the electing the knowledge will be through the interview, and the outcome of the interview will be through the drawing the individual fuzzy cognitive map. And after collecting many individual fuzzy cognitive map, we will try to collect or combine all the fuzzy cognitive maps. Then we will executed the interviews and survey with site users to see their activities and their interest in the site, and that will help us to build the dynamic conceptual model for the complex system. Next slide, please. So this is the methodology, starting with the stakeholders, interviews, then drawing the basic fuzzy cognitive map, then translating the fuzzy cognitive map to qualitative and modifying the weight of each factors, including the fuzzy cognitive and individual fuzzy cognitive map. Then we will trying to validate this collective fuzzy cognitive map through workshop, and that will help us to consider all the factors and all the users in this system. Next slide, please. So through the interview, we'll raising the many questions, starting with the natural and anthropogenic factors that affect the that influencing the state of preservation of each element of the site, and that will help us to indicate the state of the outstanding universal value for the whole site. So we will aggregate all the state of preservation of each element in the site, and that will lead us to understand the outstanding universal value. Even we will collect the management activities and why the stakeholders taking these kind of activities, when and how, and the collaboration, their aims from these kind of interventions, and their interest and their concern about any kind of things. Identifying the concept, the factors or the concept that will be in this model, starting with the social, cultural uses, local conditions and climate change, building, development, even the natural and anthropogenic. Whatever the expert indicate that these factors will affect the system, we can consider these kind of factors. Next slide, please. So after building the fuzzy cognitive map with the site manager, with the site managers and experts, we will go through interview and survey with the site users to understand their activities and their impact on the site, and how they are playing roles in this site, and which kind of the recreational activities are important to be in this kind of site. Next slide, please. Yeah, this is one example of fuzzy cognitive map that help us to understand the system and the process and the main concept that could affect the site and how we can convert the qualitative data to quantitative data. Next slide, please. So after collecting the, as I said, the individual fuzzy cognitive map, all these fuzzy cognitive map will go through matrix, and we will integrate it to one fuzzy cognitive map. It's called collective fuzzy cognitive map, and then we will decide the rules how we can apply our dynamic model. Next slide, please. So after this process, we will understand that there is a word cultural dynamics conceptual model. Then we will translate it to agent-based model that will help us to predict and monitoring each element in the site, and help us to test such kind of intervention based on many scenarios regarding to the tourism, regarding to the preservation process of the site. So through the agent-based modeling, we will planning for many kind of scenarios help us to understand the system. And the last to wrap up, that this is one example of how the cognitive map, the management cognitive map dealing is starting with such kind of influence that impact the physical fabric, and the local government is supposed to take a decision regarding to such kind of to the level of the damage or influence, and based on the regulation of UNESCO and the guidelines coming from ICROM, they have to consider it to restore or to reconstruct any kind of element in the site. And this will help us to understand the state or monitoring the state of the outstanding universal value of the site. And this is my project. So I'm looking, you are welcome to just to enrich the knowledge of the factors that influence the sites.
Thank you very much, Amira, for that very detailed description of a project which is starting out, and it'll be absolutely fascinating to see the kind of the end product as you begin to get information and the fuzzy cognitive models come to various conclusions. So it's very interesting to see a project at its very beginning or at the beginning stages, and it'll be equally fascinating to see it as it works its way through to practical recommendations on the ground. So thank you very much for that. We're going to move on to our last speaker, and this is Mark Kanata, who is a conservation architect with over 20 years of pragmatic experience. He's worked in New Zealand, he's worked across the Middle East, he's worked across Europe, and in 2019 he founded Cassandra, which is the first integrated decision support system to manage climate change in heritage environments. So Mark, over to you.
Thank you very much, John, and hi everyone. It's a pleasure to have these conversations and see all the different approaches to basically tackling these major issue with lots of different aspects around the world. Just a brief introduction to build upon what John has just said. As he said, we're conservation architects by trade, and many of the lessons that we learned dealing with historic buildings, historic contexts and World Heritage Sites have actually been instrumental in developing Cassandra. Firstly, obviously the understanding that you need to have, we're dealing with complex systems, complex environments, and you need to have knowledge and understanding of the data that you're collecting and you're analyzing. And second, the ability of maintaining at the same time a strategic view and a detailed view, because obviously both apply and both have an impact on what we're looking at. And thirdly, I'd have to say, probably the other lesson is that of having, before doing anything, a whole array of alternative options before you implement any change to the sites that we're dealing with. Next slide, please. Cassandra effectively is composed of two parts. It's a software. We started developing it for historic sites, but we've now applied it on other sites as well, including a motorway in northern Italy, of all things. So it's composed of two parts. The first part is a digital twin, which obviously is a virtual mirror of what is in the real world. So we create a model which is based on building information modeling, which has everything from the topography of a site. Obviously, it's all geo-referenced as well. Climatic conditions, we model the hydrosphere, the flora and fauna in some cases, all the way down to buildings, infrastructure, and machines. Next slide, please. So once we've got this digital world, all the entities within this digital world are analyzed and given a resilience score. Often what we find when dealing with climate change is that there tends to be focus on one or another of parameter, for instance, carbon or energy or green spaces. But what you end up losing is the overall complex picture. And complex doesn't necessarily mean it has to be complicated. So we embarked on this idea of measuring and scoring resilience along these 12 parameters. And as you can see, there are 12 parameters that are both qualitative or quantitative. And we give them a resilience score to each and every one of them. Now, just a quick word about why we're measuring resilience. When we're dealing with climate change, often we end up having to tackle the idea of risk and creating risk maps or probability of an extreme weather event happening or not happening, and preparing for something that we can predict within a margin of error, obviously. We decided to use resilience instead as our basis because effectively it allows you to concentrate on the strengths of your asset, on the strength of what you're dealing with, whether it's a historic site or something else, and increasing that strength and analyzing and verifying where maybe some of the weaknesses are. Next slide, please. So here is a little bit of a snapshot of the database that we have created. So you see on the left there are the 12 main parameters. Underneath these parameters, there are hundreds of sub-parameters. Next slide, please. So for instance, for a building, we will have all sorts of different aspects, and each one of these aspects contributes to a resilience score. Next slide, please. And here, for instance, we've seen one related to buildings and one related to heritage. But the most important things out of these 100 or hundreds of sub-parameters is actually the relationship between them. We have something like 1 million relationship links at the moment. And that means, for instance, what happens to a site when you plant a tree? Or what happens when you decide to create a protection from flooding? What happens to everything else around it? So because the understanding is obviously that everything is connected, and the actions that we take need to be based on the fullest possible understanding of the consequences of all our actions. Next slide, please. So once we've established an initial score of the environment that we're studying, for instance, here there's just an example that says we're at a score out of 100 of resilience of 54.5%. You can immediately see which elements are performing or underperforming, if you want. So you can zoom in to the aspects or the elements. So for instance, if there is a particular site or a particular part of a site or a building or a tree that's performing badly, you can actually prioritize your interventions and prioritize your expenditures in the areas that are greater need, or the ones where you can have greater resilience. Next slide, please. So just a quick snapshot of the process that we go through. Obviously, we start off with data acquisition, and sometimes what we found is that we already start a project with some known problems, whether there are flooding, whether it's landslides, or whether it's energy consumption. And so we end up acquiring all the geographical information, whether it's based on GIS or cartography, and obviously lots of other data that we analyze and create the digital twin. And that's a cyclical process in which we create a digital twin, analyze it, and then get to a resilience score, as you've seen, of the current situation. Then moving on from that, we then alter the parameters that we have measured or add in new ones. And I always describe it as one of those large desks in a recording studios with all the levers and all the buttons, and we start tweaking things and creating scenarios. The scenarios basically can be of two types. They can be active scenarios or passive scenarios. By passive scenarios, we mean situations that are outside of the control of the site that we are looking at. So for instance, in a situation like where we consider as a base scenario RCP 8.5. So what will happen by 2100 if there is no mitigation in terms of climate change. Active scenarios might mean what happens if you decide to decide to predict what a change that you are going to do to your site. So we'll have a whole raft of scenarios, and out of these scenarios, there will be a best fit scenario in terms of the resilience score, so the one that has the highest resilience score. That doesn't mean necessarily that is the one that will be implemented, because there are obviously other issues come about that might be, for instance, ease of funding. It might be cultural or, let's say, even political priorities that will push a scenario rather than another. So at the end of our process, we create what we call an adaptive pathway plan. And this allows you it gives you certain thresholds in relation to resilience by which you need to make a decision effectively. It gives you also a timeline for decisions. And this is why we call Cassandra an integrated decision support tool, because of the mixture of information and the ability to make decisions. Next slide, please. Now, we've developed this over the last 4 or 5 years, and we've been lucky enough to apply it in many different environments. Not all of them are obviously coastal, but a lot of them are dealing with similar issues. Next slide, please. One of the things I wanted to end on, really, is the other aspect of Cassandra. First of all, which you'll have intuitively understood, is that it acts as a data consolidator. Another of the issue of trying to communicate complexity in a simple, understandable, and intuitive manner. We're dealing with lots of different types of data and sometimes lots of jargon when it comes to talk about climate change. So as architects, we always think that a picture says 1,000 words. So here's sort of an image of a before and after of a couple of scenarios on a riverside environment. Next slide, please. And on a coastal one. So what you see in the colors, the red, yellow, and green, are the levels of resilience. So we can even go and click on an element within the model and understand why, for instance, one of those elements has a low score and it's in a red color, which allows you also to communicate the importance of resilience to climate change to lay people, and also to communicate what the scenarios might be. Next slide, please. And I would like to conclude on this slide. That is effectively where we started from in our exploration of Cassandra and climate change and the UNESCO World Heritage Site. This is an image of one of the scenarios that we developed for the Venice Architecture Biennale out of Cassandra for the city that I'm speaking to you from, Modica, here in Southeast Sicily, which is a UNESCO World Heritage Site. And we wanted to communicate with this image how each element of a possible scenario can contribute to the resilience to climate change of the overall city. Thank you very much.
Thank you, Mark. Again, a wonderful presentation. I particularly liked I love the idea of this digital twin, There seems to be, obviously, there's a lot of data to collect, and that might feel very time consuming. But the opposite is, if that happens in real life, there's an awful lot more cost involved. So I really like that idea of digital twinning and how you can test that as a model. And that's obviously been a theme of all the presentations, for which thank you all. I had one kind of initial question, which is related perhaps to that theme itself, and I think it's picked up somewhere else in the Q&A, is that there is a lot of input required in all three of your pieces of work. How transferable do you think that work is? Obviously, you're looking at some of you are looking at very site-specific things, whether it's the Flemish coast or whether it's Oman. But I was just wondering how transferable these techniques you feel can be, and also perhaps a little bit about affordability. Does anyone want to pick that one up?
I can say something, John, if that's okay.
Yeah, lovely.
Well, there's probably 2 or 3 different answers to that question. Firstly is the issue of at what level of detail do you need to get into to solve the problem? And obviously there's different levels of looking at the problem and analyzing it before you get to, you don't need to have all the data to be able to understand what the problem is and what the potential solutions are. For this reason, we've developed a scale system where we have different levels of Cassandra, some based on simply information that's readily available online, and a second level that is based on whatever is available online, plus information that is provided by the client, and a third one that includes surveys such as LiDAR surveys, etc. That also means that from our experience, certainly the approach is transferable to also all types of sites. As I said, we started off with the World Heritage Site. We've now analysed islands. We've looked at, as I said, a motorway. We're currently doing an urban campus and about to embark on 3 European cities. So I think the approach of gathering data obviously is time consuming, but it's very important at the beginning to understand the nature and of the problem and of the scale at which you need to look at it, whether it's 1 to 25,000 or 1 to 500. For instance, the resolution that we get down to is 0.5 meter by 0.5 meter, which is obviously really important when you're dealing with historic context. You can't just use GIS on historic context.
Fantastic, thank you. And I think Amira as well, you've answered that question in the chat, but maybe you want to also tell us, because you had the same challenge, the same question from Alex about transferability. Do you want to pick that one up?
Yeah, thank you. Yeah, actually, my innovation of my project in the approach by integrating multi models together, and that will help us to generalize the model even under scarcity of the data. You can use this approach and test the intervention of the policymakers, or test the intervention or predict the prediction of any kind of events, for instance, the flooding or the erosion process and so on. So it's by playing with the measurements. So we are trying to generalize the model to be accessible to use in other sites, even in other contexts.
Thank you, Amira. And Sukin, is there anything that you want to add to that answer?
I think we're doing similar things again. Also here, the method that we're using, the GIS, the data collection, all of that is transferable to elsewhere. And then it's a matter of scale as well. For us, we're still playing around with to what extent do we need to go into detail, or how generalized can we be with this modeling that we're doing, and what types of results does that get us? So that's something that we're testing now, because of course, if we feed all our details into the modeling, it takes ages of computing time. So there's some issues involved there as well, and something we're still looking into.
Fantastic. Thank you. Thank you all for that answer. As I say, I think the ambition clearly for you all and this whole program is to be able to produce something which is shareable, which the learning can be duplicated elsewhere, which obviously makes perfect sense. I'm going to have one more question answered, which came up early in the chat, and then we're going to go into the breakout rooms. So this one came from Benjamin, which is about the spatial resolution, kind of recommended. What's the best spatial resolution recommendation? Alex, I know you picked this one up, and I've seen the actual application of your answer, but perhaps you can pick this up too.
Yeah, sure. It's a really, really good question, Benjamin, and I think it's, in a way, one of answering it, or finding the actual solution is going to be one of those key advances that maybe we could make in the whole kind of collaborative fight, if you like, against climate change. Because although global digital elevation models are available, you can get space shuttle data, for example, that's a little bit old now, but that has been superseded by some other data sets. It's actually really difficult to get hold of global reliable data sets at sufficient resolution for looking at coastal areas, which I think is what your question is about. So those data sets tend to be nationally specific. So I put in the chat there the Climate Central coastal screening tool, which I think is one of the better sort of global level models that I've looked at. But in terms of getting hold of the data itself that can be published, publicly available, shared, manipulated, and so on, that has to probably be on a nationally specific basis, particularly at high resolutions, unless anyone knows any better. I mean, the Climate Central have talked about deriving their data sets from the NOAA, National Oceanic Atmospheric Administration. I think their data sets, but they only relate to the US, of course, not to the rest of the world. And again, it's a similar sort of thing for the UK. But again, if anyone knows better than that in terms of particularly global data sets for coastal areas at high resolution, then by all means, it would be good to find out. But that's about the best I know, I think.
Right. Thank you, Alex. I'm going to move us on because we want to have some time for conversation and discussion. So the idea next will be that you'll each be sent to a separate breakout room. So it'll happen automatically. Kira will just transport you to one of several rooms. And then within those rooms, we just want you to spend 15 or so minutes having a think about what you've heard today. I think we're particularly interested in knowing how, what did you think about the methodologies and approaches to conserving heritage proposed through the modelling that our three presenters have wonderfully challenged us with. And then the second question is, can mapping, modelling and monitoring such as this help address the impacts of climate change on a site that you work on or care about? So we're interested in again in that transferability of ideas and solutions. And indeed the opposite, we're also interested in understanding what the barriers are. So, why those approaches might not work, or what are the constraints for those approaches. So those are the general questions. It's feedback on those issues. So we're going to go into breakout rooms, and I say we'll probably close those rooms at 5:20. I'll ask someone to in each room just to perhaps lead off, someone to record and report back, and then we'll come back at 5:20. Perhaps in that case, I might just start off with, unless Hannah or Emily, you want to report back on room 3, is there? I'm quite happy to do so, but would you like to say anything about that?
I'm happy for you to do it.
Okay. All right. I think room 3 had a really useful conversation. I think that it was interesting to see that, well, I think 3 points we came up with from room 3, which I picked up. There could well be others. One is this idea of how do you record and model the intangible elements of of heritage in this context, and how do you model the value for that? So I thought that was a kind of very interesting point, which we've kind of started to unpick, but haven't totally unraveled that one. Secondly, we have Hannah, who's from outside of the kind of cultural heritage world, working for Arup on risk assessment. And so I think what the point of that conversation was how the heritage world can be looking at those for whom risk assessment is their business. Now, what's coming down the line? What's the new innovation in that world which we can use in ours? And then the final thing that we discussed was around storytelling, and how that came through very strongly in the presentations, and how important storytelling is to kind of democratize these conversations, to access the various different stakeholder groups. And we were also looking a little bit at SciArc and some other kind of storytelling platforms which are well worth sharing. So I'd say those are the 3 points from group 3, unless there's anything else that group 3 people would like to add. I'll take silence as assent. How about groups 1 or 2? Does anyone want to pitch in?
Can't remember which group we were.
Whichever group you are, Rob, you can talk.
Well, I was wondering whether or not Sam might say a few words, because he was wonderfully eloquent about about data to knowledge to value, and how you engage people in that, and particularly back to storytelling again. Sam, do you want to say anything about or reflect any of your comments?
Oh God, put me on the spot.
I'm sorry, Sam, but it was going so good. I wanted to hear it again.
Oh no, I've forgotten what I said now. So Sam Scriven, I'm a geologist. I work on the Jurassic Coast Natural World Heritage Site in the southern coast of England. I think the point I was trying to get across is that a lot of the discussion has been about data in the service of heritage sites, but I feel like it's really important the other way around as well. The heritage sites in service of data, because there's a hell of a lot, too much data out there, but the heritage sites give a real focus to how we use it and apply it and interpret it, and can convert it, as Rob said, into that real powerful tool of storytelling to help us understand places like coastlines in the long term, so how things have changed, and then project that into the future. One of the questions we sometimes ask or pose to our audiences and our communities along the coast is, what kind of coastline do you want in the future? And what is it therefore you value about the coastline now? And what is the relationship of the things that you value to ongoing change? That's the key thing, because change is continual on coastlines. It's not just a matter of the current climate change. It's always been happening. And the coastlines we have and love are a consequence of change. And so it's about relearning to embrace that change as a part of our shared heritage, I think, is where the heritage designations can take us. It's difficult to get there, or at least more difficult to get there, if you don't have that real strong heritage identity that can provide that launch pad for conversation. I hope that was all right, Rob. I don't know.
Sounded very good to me, Sam. Thank you for that. Alex, you were in room 1. What about room 1?
Yeah, thanks, myself and Mark. I was just going to say, Sam, that was really, really interesting. I hope that someone in your group, if not you, can type some of that in the Padlet. That's part of that link if you haven't already done so, because we're trying to capture as much as possible some of these fantastic points and ideas. So do make sure that that's covered. I think the link should be in the chat. Do that. Should only take a couple of minutes. So yeah, and again, okay, I can summarize a little bit, and then Mark as well was doing this. Anyone else in my group, feel free to shout out if you like. So we had a really broad-ranging discussion, as always with these. Particularly, there was a question about how we how can we make our data more visual? How can we develop visual tools to make sure that the data that we're collecting is more relevant? And how to, that really all started with a discussion a little bit about how to make some of the sort of traditional knowledge and traditional data rather than scientific data more relevant and more visible, let's say, as well. And that sort of led to the question about when is resistance rather than resilience coming into the idea of sort of conservation of heritage, and therefore actually attacking the cultural significance or reducing the cultural significance of the very things that we're trying to maybe look after. And then I think one of the key things as well beyond all of that was how can we make the data available through that sort of heritage lens? How can we make data more cost effective? And we came up to the gathering of that data more cost effective, and we came to various ways of doing that, one of which being to look at more publicly available data sets that are out there in terms of remote sensing data sets, for example. But also, if we have a culture of short-term projects, perhaps it's difficult to find the investment to get the equipment or the technologies we need. Again, something that we found within Coastal Connections, sharing that idea to overcome that, was to group together with different organisations that might find different uses for the data that are being collected through those sensors or technologies. So in other words, saying, well, actually, teaming up with another organisation or two to say, well, actually, we're thinking of getting this type of technology, this type of sensors, whatever those could be for monitoring. Actually, this would be very useful for you as well. Why don't we group together, and then perhaps we can have a monitoring system and data collection that outlives that existing project and potential use, so that it is a more versatile data set. So the whole idea again of looking to be collaborative in how we approach these things is often the way forward. I don't know or anyone else. I think Andrea, maybe in our group. Yes, feel free to chip in.
Again, I'm taking silence as assent.
Okay, yeah.
Final, I don't think we've heard from group two. I don't know if Amira, you've got anything that you want to add to the conversation so far from the group two room? No, it's
actually, I want to appreciate the suggestion of I think Professor Benjamin. He talked about his project and the significant of using the global approach or global data availability, even under lack of uncertainty, but maybe that will help us to predict at least the most important significant factors that influence the World Heritage Sites. So yeah, this is our discussion, and then we discuss such kind of sharing such kind of how we can use these kind of methods to translating the qualitative and quantitative data and so on under scarcity of the data. Yep.
Right. Thank you very much, Amira. I'm conscious that we are on time. So just to kind of wrap up, I think that obviously the whole purpose of these workshops and the fact that we record them is to try and make sure we capture as much information as possible so that we can then share it. One of the ways that we're going to share that in the future is that each of the presenters who've talked at these workshops will hopefully provide under a certain format a short summary of their project, their initiative, their bit of research, so that in the end of the 6 workshops, we'll have this whole raft of information which we can share amongst other things. So that's something to watch out for. I think on that note, I just want to thank the Alex and Sudkin, Amira and Mark for those really useful conversations about the work that you're engaged upon. So thank you very much for presenting to us today and sparking those conversations. The next workshop is on the 22nd of May and is about reimagining loss, which again should be a very interesting and challenging conversation. So I'd urge you to attend that one as well. But apart from that, thank you all very much for attending. Enjoy the rest of your day wherever you might be. Thank you very much.